Hello everyone, welcome to the YouTube channel MS Chem Insights of Dr. Aksa Habib. Today I am going to discuss the second part of catalysis, that is mechanism of homogeneous catalysis. As the example I am going to discuss about homogeneous catalysis involves different types of reactions and during different steps. So I consider it important to discuss these types of reactions. Basically, there are two types of reactions in organometallic compounds. These are simple addition or dissociation reactions, which involve either addition or removal of ligand without any change in oxidation state of metal, although the coordination number of metal changes, but the oxidation state of metal remains unchanged. While on the other hand, oxidative addition or reductive elimination reactions involve addition or removal of ligand with change in coordination number as well as change in oxidation state of metal. So these types of reactions are given in this table as well. You can see in the simple addition reaction, the coordination number of metal changes, but its oxidation state remains constant. And in the simple dissociation reactions, when ligand is dissociated, coordination number changes, but the oxidation state remains unchanged. In oxidative addition reaction in which ligand is added in an organometallic compound, coordination number increases with increase in oxidation state of metal. And in the case of reductive elimination reaction, when a ligand is removed from a complex, coordination number decreases as well as its oxidation state also decreases. Oxidative addition reactions involve both increase in coordination number and oxidation state of metal. For example, this is an organometallic compound with 16 electron of central metal atom, and this is a new compound or ligand which is to be added into this compound. So when this is added to this compound, its bond is broken and each part is added individually. If we consider this X as an anionic ligand and this Y is also as an anionic ligand, both of these anionic ligand will carry -1 and -1, that is -2 charge. So in order to this -2 charge, this metal has to compensate this charge, so its oxidation state will be decreased by +2. And when ligand is added, obviously its coordination number also increases from n to n+2. Here is an example of oxidative addition reaction. This is an organometallic compound of iridium metal, and this hydrogen is being added into this compound. In the formation of intermediate, you can see that this hydrogen is added as a dihydrogen, but after that this bond will be broken and each hydrogen will be added as an individual hydride ion. So this will carry -1 charge and this will carry -1 charge, so the metal has to increase its oxidation state by +2. In the reductive elimination reactions, which involve the elimination or expulsion of a ligand or molecule from an organometallic compound. This is the reverse of oxidative addition reaction, where the oxidation state of metal increases by 2. Here the oxidation state of metal decreases by 2 when a ligand is removed. For example, this X and this Y is being removed from this compound, so this will carry their negative charge along with them, and thus metal has to decrease its oxidation state as well. Again, here is another example in which methyl and hydrogen groups are going to be removed from this compound, and when they are removed, the coordination number of this complex decreases, and also its oxidation state decreases by 2 degrees. Third type of reactions are insertion reactions. As the name indicates, it involves the insertion of one molecule into the metal ligand bond of an organometallic compound. Basically, insertion reactions are of two types, that is 1-1 insertion and 1-2 insertion. In 1-1 insertion, only one atom is inserted between metal and ligand while the other metal is attached to the inserted atom. For example, if we number this X as 1 and this Y as 2, so X is inserted between both the atoms, so it will be called 1-1 insertion. For example, this carbon monoxide is going to be inserted between this manganese and methyl group, but when it is inserted, only its carbon is actually inserted while its oxygen goes with this carbon. So this is an example of 1-1 insertion. While on the other hand, in the 1-2 insertion, both parts of the compound are being inserted between metal and ligand. You can see this carbon number 1 and carbon number 2 both are inserted between cobalt and hydrogen. So this is 1-2 insertion reaction. Now I will discuss the example of homogeneous catalytic hydrogenation reaction of olefin in the presence of Wilkinson's catalyst. As this reaction looks very simple, but actually this is not very simple reaction. It is a very complicated reaction which involves these 5 steps. Each step involves a separate reaction which I have already discussed, like oxidative addition, ligand dissociation, coordination or insertion, and reductive elimination. So I will discuss all these steps one by one. In the first step, the catalyst which has a vacant site for one of these reactants, that is hydrogen. So hydrogen is added into this catalyst. As addition of hydrogen or ligand is called oxidative addition, which involves a change in coordination number as well as change in its oxidation state. As you can see, the oxidation state of rhodium is +1 here, but when hydrogen is added, its oxidation state is increased by a 2 degrees, that is from +1 to +3, because 2 anionic ligands are added into this complex. Now the complex is fully saturated, so in order to create a space for the other reactant, that is olefin, one of the ligand of this complex has to be removed, which is called simple ligand dissociation process, which involves only change in, which involves only change in coordination number, but the oxidation state of metal will remain same, that is +3, and its electron count will also be decreased from 18 to 16 electron, because phosphine is a 2 electron donor ligand. And in the previous step, hydrogen was added, so each hydrogen was 1 electron donor, so its electron count was increased from 16 to 18. But now phosphine has been dissociated, so its electron count is again decreased from 18 to 16 electron. Now you can see the space or vacancy for the olefin has been created. So in the third step, the olefin will be coordinated into this complex like this, and during coordination step, it will provide its pi electrons to this metal. So its electron count will be increased from 16 to 18, but its oxidation state will remain same, that is +3 and +3 in this case. After the coordination, it will be inserted between this metal and this hydrogen, and when it is inserted, its pi electrons are no more available to the metal, so its electron count will be decreased by 2 degrees, that is from 18 electron to 16 electron, because the hydrogen which was directly attached to this metal has also moved away from this metal. So electron count is decreased, but the oxidation state of metal is again same. After the 1-2 insertion of this olefin, the final step involves reductive elimination of this saturated hydrocarbon from this complex, and when it is eliminated, the coordination number and oxidation state and electron count of this catalyst is decreased. So now it is 14 electron complex with metal oxidation state plus 1, because uh, olefin has been, sorry, this olefin carries two hydrogens, that is two ligands of this compound. That's why its electron count also decreases from 16 to 14 electron. So you can see the final product is separated. And this was all about homogeneous catalytic hydrogenation process. If you have any question or query, you may contact me via email, or you can drop your query in the comment box. Thank you very much for your attention.